I waited for the whole course to do this lesson because this is my favorite one because I get to play. Okay, a family is moving to Florida. The mover estimates their possessions will take up 750 cubic feet. Cubic feet. Cubic is that cubed exponent. That cubed exponent, that 3 exponent. Okay. Would a truck with a container 8 feet wide, 6 feet high, and 16 feet long hold all of their possessions? Let's talk about cubic feet for a second. That is obviously not area because area would be in square feet. Let's look at a rectangle for a moment. With a rectangle, the reason the area is in square feet is because there's only 2 dimensions. 2 dimensions for the square, the little exponent 2. There's only length and width, but now there's height. Watch this. You're going to be amazed at how good I can draw this. I learned this when I was like 4. Right? Told me you connect these like this. There we go. You could do 2, I bet. Okay, and there is my little rectangular solid, also called a polyhedron. So let's talk more about a polyhedron. Okay, so this is one example of a polyhedron, but there are other examples of polyhedrons. This is a rectangular solid, one example. We're going to see others in 1 minute. Okay, our next example is a cube. The cube has, again, 6 sides or faces. And notice all the faces are squares, so that's another type of polyhedron. Another type of polyhedron is a ball, which is called a sphere. A sphere is another type of polyhedron. Kind of cool. And watch what we can do. If we cut this polyhedron in half, the sphere, now that's a hemisphere. Half a sphere, hemisphere. Kind of cool. Just thought you should see that. Our next one, for whatever reason, is one of my favorites. Okay? It's like a soup can. Okay? It's the can. It's the circular cylinder. I love this one. Notice what this one's made up of, because I want to talk more about this later. Okay? This cylinder is made up of a circle on this side, a circle on this side that unfortunately does not come out, and then it's got this piece that I won't talk about yet, but then of course it's got this middle segment. So this is a circular cylinder. Okay, now let's talk about volume, because when you're putting some, sorry, forgot 2 more. I got 2 more for you, just remembered. I got this cone, so let's take a look at the cone. Look, just like an ice cream cone, but it's a cone, okay? And we got one other figure. We have a square pyramid, and here's the square pyramid. Notice its base is a square. Okay, polyhedrons are actually named by the base, so it's called a square pyramid. Okay, that's a pretty cool figure. All right, now let's talk about volume for a minute. When we were putting their possessions inside that truck, we're talking about filling that space up. That is called volume. Volume is the number of, well, let me go back for a minute. Remember when we did area? Area was the number of little square units you can get inside of a shape. Well, volume is the number of little cube fixtures. So little ones of these, little cubes you can get into a shape. Okay, that's what volume is. So you might want to, I don't know, you might want to know how much water is in this container. You might want to know how much juice is in a juice bottle. You might want to know how much cement you need in a foundation of a house. That's all volume. Okay, and we're going to talk a little bit about volume today. So let's take a look at that problem again. But before we revisit it, I have to show you this because this is way too cool. And this is why I wanted to bring in all these silly little props. Okay. In your workbook, you have the formulas of the volume of a cylinder and the volume of a cone. All right? I'm going to show you how these formulas even came about. I'm going to start with this cube. I know I didn't say cube. Just listen for a second. Okay. I'm going to take this out. I actually cut this out so it measures completely what the bottom is. Okay? I put this in here. We want the volume. That means we want to know how much this will hold. So if I take this, the area of this is length times width. So if I put it in, we have length times width, but we need more of these to fill it up. So it's times the height. It's times the height of this figure. So the volume of this, which you'll see on your formula sheet, is length times width times height, because you got the length and the width times the height of the figure. That's why it's cubic units. Now let's look at the cylinder. The cylinder has a base, right, that circles. Now I'm going to show you this. These are not the same size as that bottom. I tried. I couldn't cut it out well. I used poker chips. Sorry about that. But let's pretend it is. The area of this, remember, the area of this is pi r squared because it's a circle. If I fill that in there, how many do I need? I need as many as I can make this tall. So it's really pi r squared times the height of the figure. That is the volume of a cylinder. And that's in your workbook. The volume of a cone. Let's take the cone. And I'm going to take the cylinder, and I know you really can't see this well, but if I put the cone inside the cylinder, it doesn't fit all the way. There's actually space inside the cylinder. That's because, maybe you can see a little better this way, but that's because the volume of the cylinder is bigger than the volume of the cone. The formula, and you'd probably be able to see this a little better if we just could, but there's a lot of space to the left or the right of where that's coming down. The formula for the volume of a cone is very cool. It's 1/3 pi r squared h. What that tells me is that the volume of the cylinder is 3 times the volume of the cone. So if I take the cylinder and I take the cone, 3 of these, whatever the capacity of this is, 3 times that should go into the cylinder. So I'm going to do this. I'm going to pour it once. I'm going to try to get as close to the top without dripping. Okay. Now notice, I do it once, and I got some liquid in there. All right. Now I'm going to do it again. 2. Okay. Now watch this. Up, not filled, almost full. Are we going to make it? Okay, if this is true, here we go. 3. Oh yes, look at that baby. Right to the tippy top. Well, look at that. It's filled up. So 3 of these make the capacity of that cylinder. All right? All right, so let's revisit that Florida problem. We're moving to Florida. Oh, we're in Florida, whatever. Okay, a family is moving to Florida. The mover estimates their possessions will take up 750 cubic feet of space. Okay, they have a truck that is 8 feet wide, 8 feet wide, okay, 6 feet high. I'm just going to put 6 high and 16 long. 16 long, that's what we got. We want to know if that truck can hold 750 cubic feet. So here we go. All right, the volume, this kind of truck really would look like this, it will look like a rectangular solid or rectangular polyhedron. Here's the deal. The deal is that, remember, we said that to get the volume of this, which is in your workbook, just to make sure you understand this, it's the area of the base, which would be length times width, because the base is a rectangle or a square, so it's the length times width times the height of the figure. So volume is length times width times height. The length is 16. The width is 8. And the height is 6. We multiply this. We get 768 cubic feet. So this is how much the truck could hold. This is how many cubic feet you need. You're on your way. Go to Florida. Okay, how much sheet metal is needed to construct a water tank that is in the shape of a circular cylinder? Oh, a circular cylinder. I get to play again. So exciting. Okay, circular cylinder with the following dimensions. Length of 30 feet, diameter of 8 feet. Okay, before we do this problem, let's talk about this. Are they talking about filling this up? No, they're not talking about that. They're talking about the following. They're talking about sheet metal to construct this. And I only have sheet metal for the okay, it's not really sheet metal, it's really paper. But I only have sheet metal for this part of the cylinder. You already know the top and the bottom are circles, so I didn't really feel the need to do that. But I'm going to show you what I'm going to do. Okay? I'm going to outline with a thinner pen. I got one. It's all good. I'm going to just, because I really want to show you this. Surface area. And I'm going to talk about what surface area is. Okay, but I want to outline. I don't know if you're going to be able to see this when I'm done. I'm going to give it my best shot. Okay. Okay, let's talk about this. All right, here's the deal. We want how much sheet metal is needed to construct a water tank. So we want to know the sheet metal that goes around the middle, the whole thing, the top, and the bottom. That is area of every face, the 2 circles, and whatever this is, okay, that is not volume. We're not filling it inside. Filling it inside is volume. We want the area of all the faces. That is called surface area. That we want the area of all the surface, so we're talking surface area. I want to show you the surface area formula that we can use for this. It's really cool. Remember, we have a circle. We have another circle, which I can't rip off, so there's 2 circles. So I'm going to write this down, 2 circles, because this is going to be important. And this formula is in your workbook. And again, you never have to do this. I just want you to see where these formulas come from. Okay? There's 2 circles plus whatever this is. So now I'm going to take off my tape and try not to rip it. That's better tape than I thought. Okay, take out this tape. Okay, it's really coming. I'm going to take off this tape. I really am going to take it off. Okay, I'm going to rip it a little bit. We're okay. I'm going to take off this tape and unravel it. And what I have in the middle is a rectangle, a ripped rectangle, but a rectangle. So the middle of this is a rectangle, but watch what happened as I unwound it. When I unwound it, look at what's covered in black. It's actually the distance around this figure. What is truly the distance around that figure? Well, the distance around this figure is really the circumference of the circle. So this is really the circumference of the circle. And what is this really? This piece right here. That's really, remember how it came off? Watch, watch, watch. That is really the height of the figure. So this is the height. So watch how this formula was developed. We have, remember, all the faces. There are 2 faces. So the area of a circle is pi r squared, but you have 2 of them. So it's 2 pi r squared because you have the circle here and the circle on the bottom, pi r squared, 2 of them. And then plus the area of the rectangle, which is length times width. But the length is really the circumference of the circle. This is so cool. The length is the circumference of the circle. So that's for the 2 circles. The length is the circumference of the circle, which is 2 pi r times the width, which is the height of the figure. So that is the formula of the surface area of a cylinder. 2 pi r squared plus 2 pi r h. Why? We just showed you why. The 2 circles, and then this piece is really a rectangle that came around the midsection of that cylinder. And that top, when I unravel it, is really the circumference of the circle, and that's the height of the circle. That is so cool. All right, so now let's do the problem. So let's look at the dimensions and get it done. Here we go. That was cool. Come on, really, that was cool. Don't hold back. I know you thought that was cool. Don't hide it. All right, so surface area for this cylinder. 2 pi r squared plus 2 pi r h. Okay, let's get the dimensions down, and we'll get this done. How much sheet metal is dimension? Length of 30 feet and a diameter of 8. Length of 30 feet and a diameter of 8. When they mean length, they mean the height. Okay, look at that little drawing on your slide. They actually mean the height. So that's the length, which is really the height. Okay, so here we go. That's the diameter. We don't want the diameter. We want the radius because the radius is in our formula. Well, if the diameter is 8, the radius is half of that, so the radius is 4. Watch this puppy go. All right. 2, does it say exact? It doesn't say either one, so I have to assume it's getting all the numbers in here, times the radius, which is 4 squared, plus 2 times pi, which is 3.14, times the radius, which is 4, times the height, which is 30. Oh my gosh, aren't you glad you came today? Okay, here we go. This is 2 times 3.14 times 16 plus 2 times 3.14. Well, I didn't really do anything here. 4 times 30. I was doing my exponents. Okay, so we substitute all these numbers in, and at this point, we're going to let you use a calculator. So here comes my handy-dandy calculator. Okay, 6.28. I could do that one in my head, so I didn't bother with the handy-dandy. 6.28 times 4 times 30. Okay, now I'm going to do a handy-dandy calculator move. Ready? All right. 6.28 times 16 equals 100.48. Plus, I'm going to do this all across, okay? This whole thing across. You ready? 6.28 times 4 times 30. Here we go. 753. 753.6. Now I'm going to add these two. So I'm going to add 753.6 plus 100.48, and I get 854.08 cubic feet. Cubic feet, and we're done. That's how much sheet metal I need. Awesome. Okay, that takes care of surface area. I mean, now you can see in your workbook there's tons of formulas for all the different figures, but that's all you do when you plug in and chug in the formula. I just thought it'd be really cool to come in and show you how these formulas related and what it really meant. Let's take a look at another question. Okay, we're going to play some soccer here. Well, we're not really going to play anything, but I'm going to use a soccer ball. Okay, find the volume and surface area of a ball. Remember, that's a sphere of a ball that has a radius of 3.5 inches. Okay, so we got a soccer ball, and we want volume and surface area of the sphere with a radius of 3.5 inches. Okay, it says give the exact volume and surface area. Give the exact volume and surface area, then use the approximation 22/7 for pi. Okay, so I'm going to do it two ways. I'm going to do approximate, and then I'm going to do the exact, right? So give the exact and approximate. So here we go. Let's find the volume. Yep, both, huh? Okay, just checking to make sure I understand the question. So the volume of this sphere is 4/3 pi r cubed. Let's do the exact first. Exact means I'm not going to substitute 3.14 for pi. I'm just going to leave pi. So here we go. This is of a sphere. Ready? 4/3 pi times the radius. Okay. Now, the radius. Up to you. 3.5. You may want to change it to a fraction. You may want to change it to a decimal. But remember, we got to cube it. So if we change this to 7/2, that's going to be a big number to cube. You might want to change it to a decimal. Remember, 1/2, if I have a half a dollar, I have 50 cents, so it's 3.5. So I'm going to do 3.5 cubed. I'm going to show you how to do this. It's actually very simple. But yes, I'm going to use my handy-dandy calculator for here. So here we go. 3.5 times 3.5 times 3.5. And we get 4/3 times pi times 42.875. Now, I'll tell you what I would do. I would put this 42 over 1, 42.875 over 1, and I would multiply 4 times that and then divide it by 3. Okay? 4 times that, divide by 3. Here we go. So we're going to multiply that by 4, and I get 171.5 thirds pi. Okay, and that now, I'm not going to divide unless this goes evenly, because remember, this is the exact answer. So 5 plus 1 is 6, plus 7 is 13, plus 1 is 14. It's not going to divide nicely. I am done. 171.5 over 3 pi, and it's cubic inches. That is the exact answer. Remember they told us to do this problem, this ball problem, with the exact answer and the approximate answer. We already did the exact answer. Now we're going to do the approximate answer. To do the approximate answer, they told us to use 22/7 for pi. Since we're using a fraction, we're going to use a fraction for the radius. So right now it's a mixed number. I'm going to change that to an improper fraction. Remember how to do that? 2 times 3 is 6, plus 1 is 7, so the radius is 7/2 inches. So when we're done, remember this is volume, so it's measured in cubic units, so the answer is going to be cubic inches when we're done. And it's only going to be approximate answer, since we're approximating with pi. Okay, so the volume of the sphere, 4/3 is part of the formula, so that stays the way it is. We're substituting for pi. Remember when you substitute to put everything in parentheses. Okay, and the radius is now 7/2. And we're going to cube it. All right, so here we go. Order of operations says parentheses first. Well, we really don't have any parentheses because there's no operations inside here or here. So now we go to step 2 if we have it exponents, and we do. So here we go. Volume equals 4/3, 22/7. Nothing to do here. Here we have to take 7 and cube it, which is 7 times 7 times 7. 7 times 7 is 49. 49 times 7 is 343. And then, of course, we're cubing the 2. 2 times 2 times 2 is 8. So that's what we have so far. Now we're going to try to reduce, because there's no way I'm going to multiply these huge numbers. Okay, that's going to be a pain. So here we go. I'm going to start with the 4 and the 8. Any numerator with any denominator. So 4 goes into 4 once. 4 goes into 8 twice. Now notice I have a 2 here, but I have a 22 here, so I can reduce that as well. 2 goes into 2 once. 2 goes into 22 11 times. Now I can reduce 7 and 343. I know 343 is divisible by 7 because notice we got 343 by cubing 7. So 7 goes into 7 once. 7 goes into 343 49 times. Now we can multiply the top. 1 times 11 is 11. 11 times 49 is 539. So the volume is approximately 539 over 3 times 1 is 3 times 1 is 3. And that's cubic inches. But that's not a cool answer, because what is 539 over 3? Okay, to do this, I'm either going to change this, I'm either going to divide, or I'm going to change this into a mixed number, because it didn't tell us what it wanted for the answer. Well, first thing I'm going to do is I'm going to see if 539 is divisible by 3. And it is not, because 9 plus 3 is 12. 12 plus 5 is 17. I added the digits, and I got 17. And since 17 is not divisible by 3, neither is 539. So I'm going to change this to a mixed number. To do that, I'm going to erase what's above it. Squeaky eraser. And I'm going to get 3 divided into 539, right? Because this is 539 divided by 3. I'm going to do short division. 3 into 5 goes once, remainder 2. 3 into 23 goes 7 times, remainder 2. 3 into 29 goes 9 times, remainder 2 again. So my answer is the volume is approximately 179. The remainder is 2. I write that as my numerator over 3. So 179 and 2/3 cubic inches, and that's my approximate answer for the volume of this sphere. Okay, remember this problem with the soccer ball? We now have to find the surface area. We found the volume. Now we have to find the surface area. We have to do it 2 ways. First the exact, and then the non-exact approximation. Okay? Here we go. All right, we're going to go exact first. Exact means I cannot use 3.14 or 22/7 for pi. So 4 times pi, pi stays pi. Now I'm going to change 3.5 to 3.5. Okay, and I have to square it. Surface area equals 4 pi. 3.5 times 3.5 is 12.25. That's another trick. Ask me about it if you want to hear about it. Okay, 12.25 times 4. times 4 is 49. So we get 49 pi. That is your exact answer, but the dimensions are in inches, so it's square inches because it's surface area and area is in square. Okay? All right, now we're going to do the approximate one. All right, surface area is 4 pi squared. But remember we said we would 4 pi r squared. Let's fix that up. Remember we said we're going to use 22 over 7 for pi. We'll do that right now. So surface area equals 4. We'll put 4 over 1 because I'm going to use 22 over 7 times the radius. The radius is 3.5. But remember, we're going to have to change that to an improper fraction. 2 times 3 is 6, plus 1 is 7. It's back, so you never can lose the things you learn how to do. And we get 7 over 2 squared. Surface area equals 4 over 1 times 22 over 7 times 49 over 4. So here we go. I'm going to reduce. Okay, ready? 7 goes into 7 once. 7 goes into 49 7 times. 2 goes into 4 twice. Or I could have did this. You know what? I'm going to do this 4 with this 4, just because we've never done that. I want to show you that we can. 4 goes into 4 once. We can do that. Okay, you don't have to be right next to each other. You're just all factors. All right, so we have here surface area equals 22 times 7 is 154 square inches. And that's it. So that takes care of the soccer ball problem. All right, I think we have one more problem. Let's look at it together. Give it an exact and approximate answer for the volume of a cone that has a height of 14 centimeters and a radius of 3 centimeters. All right? So we're doing volume of a cone. We already know the volume of a cone. Here's why you should know the volume of a cone. Because we poured all that water out of it. Okay, so let's do that one together. Cone. Height of 14 centimeters. And a radius of 3 centimeters. Okay, volume equals 1/3 pi r squared h. We have an exact and an approximate. They didn't tell us what to use for pi, so it doesn't matter if we use 3.14 or we use 22 over 7. Okay, here comes the exact. Remember, if we want to use the exact one, we leave pi. So here we go. Pi. 1/3 pi times the radius, which is 3 squared, times the height, which is 14, which is 1/3 times pi times 9 times 14. Okay, I got a little squishy there. Let's stop the squishing. Volume equals 1/3 times pi. I'm going to write 9 over 1 and 14 over 1. Okay, here we go. Let's reduce. 3 goes into 3 once, 3 goes into 9 3 times. So now, and if you want, you can even write pi over 1. That's all good. Okay, 14 times 3 times 1 is, just make sure we get this right, 14 times 3 is 42. So we have 42 pi over 1, which is just 42 pi. Absolutely beautiful, but it's volume, so it's cubic centimeters. CU for cubic. Cubic centimeters. That is the exact answer, 42 pi. Now let's do the approximate to finish it up. I'm going to use 3.14 for pi. I'm going to use a different color so it doesn't all kind of get crazy. E equals 1/3 pi r squared h. Pi stays, oh, pi does not stay pi. We're not doing the exact. It's all good. I think I'm going to do 22 over 7 since we're dealing only with fractions. But you don't have to. 22 over 7 times my radius, which is 3, times my height, which is 14. All right, let's finish this up. I'm going to take the parentheses off just because it's getting a little squishy in here. 22 over 7 times 3 squared is 9 over 1 times 14 over 1. So I'm going to reduce anything I can reduce here. I'm going to use a different color to reduce. I'm going to reduce the 3 and the 9. That's about it. 3 goes into 3 once. 3, oh no, I have more. 3 goes into 9 3 times. Then we have the 7 goes into 7 once. The 7 goes into 14 twice. Beautiful. On the top, I have 22 times 3 times 2. So 22 times 3 is 66. 66 times 2 is 132. Divided by 1 is still 132. So it's 132, and it's volume, remember? So it's cubic, and it was centimeters. So 132 cubic centimeters. Awesome. And we are done. That takes care of all the mods. That wraps up this pre-algebra course. Hope you enjoyed it.